Hello everyone, welcome to the video. Today is tutorial 2 on making a project where we can detect how far away something is in centimeters using the HC-SR04 Ultrasonic sensor. So today we're going to be upgrading the project to be able to put LCD display in the project so that we don't actually have to read the distance on the serial monitors. And so basically I'm going to be showing you the circuit and then the code to make it. So without further ado, let's get started. And so basically here's the circuit. I'm going to go ahead and explain all of it. If you want to understand more about how the ultrasonic sensor works, go back in the past tutorial 1 to understand more about that. So the first pin we connect up on the ultrasonic sensor is G and D. This is going to go to the ground rail on the breadboard. Then we have the echo pin, and this pin will be going to pin 11 on the Arduino, so pin 11. And then we have trigger pin. This pin will be connected to pin 12 on the Arduino. Then we have the VCC pin, and this pin will be connected to the positive rail on the breadboard. And so then we're going to come up to the LCD display, and the first pin here is G and D. We'll connect that to the ground rail on the breadboard. Then we have VCC. We'll connect that to the positive rail to the breadboard. And then we have the VO pin. That's going to be connected to the middle pin on the potentiometer. This potentiometer is so that we can adjust the brightness of the LCD display, or more the brightness of the letters, not the brightness of the actual LCD display itself. So basically how we connect this potentiometer up is we connect one side of the potentiometer, doesn't matter which side it is, to positive 5 volts, and then the other side of the potentiometer to negative 5 volts. So then we connected the RS pin, and that pin is going to be connected to pin 10 on the Arduino. And then the RW pin will be connected to the ground rail on the breadboard. And then the E pin will be connected to pin 9 on the Arduino. And so now the next pin we connect is D4, and this pin will be connected to pin 5 on the Arduino. Then we have D5, and this pin will be connected to pin 4 on the Arduino. And then we have D6. This pin will be connected to pin 3 on the Arduino. And then we have D7. This pin will be connected to pin 2 on the Arduino. And then we have the anode side of the LED backlight of the LCD display, and we'll connect that through a resistor, which is 330 ohms. It could be anywhere between 200 ohms up to 470 ohms you can use in this case. In my case, I'm just using a 330 ohm resistor. And then the cathode side of the LCD display backlight will be connected to ground. So then we connect it to the ground rail on the LCD display. And then we connect the G and D on the Arduino to the ground rail. So it provides negative power to all of these things on the breadboard. And then we connect the 5V pin, which provides positive 5 volts, and we'll connect that to the positive rail on the breadboard. And so basically that is how you connect up the circuit. So go ahead and connect that all up, and then we will continue. Okay, so now here is the code. And so the first line of code that we do is we include the liquid crystal library. This should be already installed for you, but if it isn't, you can go ahead and just go to library manager and type in liquid crystal library and download it. And if you want to know more about this library, feel free to look in the description for a video on showing you how to use the LCD display with Arduino. So basically this is the library that helps us use the LCD display. And then we have these 4 pins right here. This is for the ultrasonic sensor. So we have trig pin, which is pin 12, echo pin, which is pin 11, and then we have duration. It's going to be storing how long it took the sound to go out, come back in microseconds. And then we have distance. It will be storing this the distance in centimeters. And then here are all of the constants of our LCD display. And so these are all the pins that we have connected up to the Arduino that have to do with the LCD display. And then we give the liquid crystal library all of those pins, as you can see right here. They all have to be in order like this right here, because the liquid crystal library does not know which pin is which if you don't put it in the right order. And then also we name the LCD display, which is LCD. And then we go into the void setup, and we go ahead and do pin modes for trigger pin and echo pin. Trigger pin is going to be an output, and trigger echo pin is going to be an input. And then we do LCD.begin. So just like the serial monitor, we need to begin or start it up. So that's what we do here. I forgot to take this out because sometimes always when I test the code, I always have that. And so then we had the void loop, and I do digital write trig pin high. So this is just turning it high. Then we delay 10 microseconds, which is very little bit of time. All we need is so that ping is able to get out. And then we turn it low, and then we wait and see how long that pulse takes. And that will tell us how long it took for the sound to go out and come back. So it'll give us the speed on how long it took. It will give us the distance on how far away something is in centimeters. And it'll put that into the distance variable. And if you don't understand about this, go back in the past videos. I explained more about this. Okay, and so now we come down to the next line of code and we do lcd.clear. This is going to clear all the information, all the old information that we had on the LCD display before, and it's going to clear it off and get ready, and so that we can go ahead and put the new information on the LCD display. So that's what we do. We do lcd.print, and we print distance, and then we do lcd.print distance, the variable distance. So this is going to print out the actual number, and then we do lcd.print cm for centimeters, and so then we have the word distance, and then the actual distance of number of centimeters, and then we have cm next to it, meaning centimeters, and so that will print it out, and we do that every half a second or 500 milliseconds, and then we just do this over and over again. So basically, now let's go ahead and see our project in action. Okay, so now here is the project, and as you can see, the sensor is reading lots of different numbers in centimeters. But now if I put this at like 4 centimeters away, as you can see on the LCD display, it says 4 centimeters. If I go to 5 centimeters, it says 5 centimeters. If I go to 8 centimeters, it says 8 centimeters. Go to 10 centimeters, it says 10 centimeters. If I move to 11, it says 11, and so on as I start moving back. So anyways, that is the project. And so basically, if you like this video, consider giving this video a like. Also comment down below if you have any questions, and consider subscribing if you want to see more content like this. Thank you all, and have a great day. Bye.